Basically, this is the tips and the tricks to integrate trigonometric functions. Okay, so firstly, let us do a bit of recap on the basic rules of integration. So I already teach you this in lesson 1.2. So integrating sine ax dx, so this is equal to negative cos of ax, and then we have to divide by the coefficient of x, which is a. So divide by a and then cos plus with c. So if we have to integrate cos ax dx, so this is sine of ax divided by the coefficient of x, which is a, and then plus with c. Integrating second square ax dx, so this is equal to tangent of ax over a plus with c. And let me give you one more example, that to integrate tangent square of ax dx. So what do? Is we use the identity. So we know that tangent square of ax plus with 1 is actually equal to secant square of ax. So we use this identity, we make tangent square as the subject. So we bring positive 1 to the right hand side. So this one will become integrating secant square of ax minus with 1 dx. So integrating secant square, so that one will become tangent of ax, again divided by the coefficient of x, which is a, integrating negative 1, so it will become negative x plus with c. Okay, so again, the basic rule of integration, integrating sine ax, cos ax, secant square, and if we have tangent square, we must use the identity, change it into secant square, and then we can integrate them as usual. But what happened if we didn't have sine but sine square, not cos but cos square? Okay, so for example here we have sine square of ax, cos square of ax. So the way we solve this is actually by using the double angle formula. So we're going to use the double angle formula. In this case, we are going to use the cos of 2 theta. So sine square of ax, we can actually use the double angle formula. So change this one, it will become 1 minus cos of 2ax. So the theta here is ax, so it will become 2ax. And then divide everything by 2 and then dx. So after that, we're going to integrate them as usual. So you can choose to bring 1/2 outside first, so that inside here you will be left with 1 minus cos 2ax, or you can choose to separate them directly. So we can have 1/2 minus 1/2 cos 2ax, and you can integrate them. So if we have cos square, so again we are using the double angle formula. So we change this one to become 1 plus cos 2ax over 2 dx, and then you can integrate them as usual. So another example that might not look too obvious. So if we have a multiplication between sine and cos, but both of them having the same angle. So a product between sine and cos, so both of them having the same angle. So the way we solve this is again by using the double angle formula, but instead of using cos, we are going to use the sine of 2 theta. Okay, so what do we know is that if we have 2 sine A cos A, this is actually equal to sine of 2A. So that means if we make sine A and cos A as the subject, we can bring the 2 to the right hand side. So sine A cos A is equal to 1/2 sine of 2A. Okay, so now we can change this one to become half of sine 2a dx, and then of course you can integrate them as usual. So a is actually in terms of x, but I find it a little bit messy if I write down the x, so that is why I simply wrote down a, so that you can look at the formula much more easier. Okay, but this is for sine and cos with the same angle. What happens if we have different angle? So here we actually have different angle. So we have sine A, sine B, so different angle here. Over here we have sine A, over here we have sine B. So both of them have different angle. Cos A and cos B, again, both of them are having different angle. Sine A and cos B, again, both of them are having different angle. So what do is we use the formula to change from product to sum. So if we have a multiplication, we cannot integrate them directly. So that is why we have to use this formula. So we're going to change from product to sum, and then we're going to integrate them after that. So sine A and sine B, we are going to use the formula, so it will become half cos A minus B minus cos A plus B dx. And once you substitute the A and the B inside here, simplify a little bit, and then you can integrate them as usual. So if you have cos A and cos B, use this formula, and again substitute the value of A and B, and you can integrate them as usual. So I forgot to mention that actually both A and B are actually in terms of x, but again I find it messy if I wrote down the x, so that is why I didn't write down the x, but you should know that both of them are something in terms of x. So over here we have sine A cos B, so the formula will be half sine A plus B plus sine A minus B dx. So again substitute the A and the B, and then you can integrate them as usual. So again, keep in mind that if we have a product between two trigonometric functions, we cannot integrate them directly, which means we must use the formula to change from product to sum. Okay, so how do we integrate sine square of x, cos square of x dx? So actually we have two different methods to integrate this. So the first one is we change both of them by using the double angle formula. So integrate 1 minus cos 2x over 2, and then another one is 1 plus cos 2x over 2, and then of course dx. So multiplication, so you don't get, you must put them inside a bracket. So simplify a little bit, 2 and 2, it can become 1 over 4. Integrate, then you can expand the bracket. It will become 1 minus cos square of 2x dx. Okay, so what happened here is that we have cos square. So that means again you have to use another double angle formula. So we know that cos square of x is equal to 1 plus cos 2x over 2. But now we have cos square of 2x. So every time I see x here, I should change the x to become 2x. For the right hand side, I should do the same thing. Every time I see the x, change the x to become 2x. So that means if I have cos square of 2x, it will become 1 plus cos, so 2 times 2x, so this one will become cos 4x divided by 2. So this is 1 over 4, integrate 1 minus, and then inside here you are going to have 1 plus cos 4x over 2 dx. So we change everything into a single fraction, so change everything inside the integral into a single fraction, so this is 1 over 4, and then we have 2 minus 1 minus cos 4x over 2 dx. Okay, so I forgot to mention that you have to multiply the negative with both of them. So that is how we get -1 and negative cos 4x. So to simplify a little bit, I'm going to bring the 2 outside here, multiply with 4. So I'm going to have 1 over 8. Integrate, so 2 minus 1, it will become 1 minus cos of 4x dx. And then we can integrate them now. So this is 1 over 8. Integrating 1, we get x minus sine of 4x over 4 plus with c, of course. Okay, so this is the first method. So for the second method, we can actually bring out the square. So we are going to have integrate sine of x cos of x square dx. And then like before, we can use the double angle formula. So this is actually sine of 2x over 2 with the square, of course, dx. So square both of them, both our numerator and our denominator. So we are going to have sine square of 2x. So since 2 square is simply some constant, like we bring them out. So I will have 1 over 4 sine square of 2x dx. And then we can change the sine square using another double angle formula. So it will become 1 over 4 integrate 1 minus cos. So instead of 2x, it will become 2 multiply with 2x over 2 dx. So if let's say we have sine square of x, so sine square of x is 1 minus cos of 2x over 2. So if I have sine square of 2x, change the x to become 2x. So that is how we get 1 minus cos 2 times with 2x over 2 dx. So let me bring the 2 outside. So we have 1 over 8. Integrate 1 minus cos of 4x dx, which is similar to what we have here. So if you integrate this, again we are going to get the same answer.